Hello students. In this lecture, we are going to discuss how to solve a trigonometric equation, especially how we find out the principal, particular or general solution. For that one, let me take a couple of questions. The first one, we need to find principal solution for sin x equals to 1 by 2. For only value of x which I am aware of right now, it is x is equals to pi by 6, which will give me 1 by 2 as a result. I need to get, is there any more solution for which sin x will give you a 1 by 2? Since we know sin is positive in coordinate number 1 as well as in coordinate number 2. So there definitely will be a solution from coordinate number 2. But how to access this another angle? As we know the reduction formula, the value of sin pi minus theta is actually equals to sin theta. Once you substitute theta equals to pi by 6 there, you end up getting another response, and it is sine 5 pi by 6 will give you same value as of sine pi by 6. So we have two principal solution for sin x equals to 1 by 2. Let's try it again. For this time, we have tan x equals to 1. Now tan x is will give you 1 for x is equals to pi by 4 value. Am I right? Now I need to check whether there will be more solution for tan x is equals to 1 or not. I know that tan is positive in coordinate number 1 as well as in coordinate number 3. And the range of tan is from negative infinity to positive infinity. That means definitely there will be a solution in coordinate number 3. Now what reduction formula correlate angles between these two? As I know, tan pi plus theta will give you same result as of tan theta. Once you plug the value of theta, which is pi by 4 right there, we get the another solution. And it is tan pi plus pi by 4. So we have two solution for tan x is equals to 1. Now, what about cosine equals to 0? You may use the previously used method, or if you want to use the graph, then for that one, you need to draw the graph of y equals to cosine x in principal range. So there is, I draw the graph of y equals to cosine theta from 0 to 2 pi. At the same time, you are supposed to draw the graph of y equals to 0. There we have y equals to 0 in yellow. Their point of intersection are actually our solution. So the one of the solution, it is pi by 2. Another one will occur at a pi length of interval. So this will make pi plus pi by 2 will be your another principal solution. Now, before we start solving more couple of questions, we should be good at how the graph of trigonometric function. Especially, I'll be dealing with the period of particular functions. So the first graph, it is of a sine function. We know the period of sine is 2 pi. Similarly, for the cosine, it is again 2 pi. Cosecant and secant are the derivation of sine and cosine. So they will share the same length of period. Now, what about the tan and cotangent? The period of tan and cotangent are pi. The kind of attention that we give to the graph of sine and cosine as well as tan, we usually forgot that which one of the following is the graph of cosine, cosecant, and secant. Their appearance are different, but with the help of sine and cosine function, you should come to know that which of the following function is the graph of cosecant and which of the following it does represent graph of secant one. Now, let me take some more challenging problem, or first in that one we'll be solving question using the graph. How we can find out the general solution for sine theta equals to 0? I did the same thing again. I draw the graph of y equals to sine theta as well as draw the graph of y equals to 0. And I'll be checking or observing their point of intersection. As we know, these are the point of intersection which we obtained, and these solution are occurring at a length of pi interval. That means that theta can be generalizing using a variable n, where n is any integral value. So theta equals to n pi, will become the general solution for sine theta equals to 0. Now let us move to the next one. Again, graph of cosine and graph of y equals to 0 is what we need to draw. And another thing is that we'll be observing their point of intersection. So as we can see on that screen, that pi by 2, another point is 3 pi by 2, another would be 5 pi by 2, and so on and so forth. Now try to develop a relation, if there is any, between all of this solution. You would wonder that solutions are occurring at a pi length interval. That means these solution will be in arithmetic sequence. So if the sequence is in arithmetic, then we know how to write down its nth term or general term by considering pi by 2 or any of the term, any of the solution, your first term. You'll end up writing the solution will be n pi plus pi by 2, n pi plus pi by 2, where again your n be any integral value. So for different values of n, you end up getting different values of theta. Negative integers are also welcome there. Now, what about tan theta equals to 0? Directly, I'm just looking at their point of intersection this time. And there we have one is 0, another one is pi. And if you extend this graph, then you would say another point of intersection will be 2 pi. Am I right? So their point of intersection, they are present at a pi length interval. So if one of the solution is 0, let me consider 0 being your first term and pi being the common difference. So this will give me the general values of theta. It is n pi. So instead of denoting or referring your n being a natural number, I would say n can be any integral value, because there are solution in negative range also. So there we go, the general solution for tan theta equals to 0. Do try it out if you can, the how to generalize the solution of sine theta equals to plus minus 1 as well as cosine theta equals to plus or minus 1 with the help of graph. Now we have another challenging problem. This time more than one trigonometric function are participating separately. We need to check first of all, is it possible for some particular value of theta for which sine will give you negative 1 by 2 and tan will give you 1 by root 3. So for that one, I need to check coordinate first, availability of coordinate. Sine will give you negative in coordinate number 3 as well as in coordinate number 4. Whereas tan will give us positive response in coordinate number 3 as well as in coordinate number 1. So yes, if there is any possible value of theta, then definitely it will exist in coordinate number 3 only. So finally we come to know, yes, coordinate number 3 will be or may be your desired reason. So now please pay attention how we can get or access a particular value of theta for which tan will give you 1 upon root 3. Corresponding to tan, the only value of theta I'm aware with is pi by 6. But I also good at reduction formula, and according to this formula, I know reduction of tan pi plus theta will give me same result as of tan theta. The moment I replace theta with pi by 6, I will have another value of theta for which tan will give you 1 by root 3. So there we go, 7 pi by 6 is there. But still we are in the middle of the question because we don't know what sine will give us at 7 pi by 6. So for that one, check the value of sine function corresponding to this angle. Sine 7 pi by 6 is actually equals to sine pi plus theta, which is sine pi plus pi by 6. Sine pi plus theta is equals to negative sine theta. And there you go. We are getting the same result. It is negative 1 by 2. So congratulations, from all of the quadrant, we only get a solution so far. It is what? It is 7 pi by 6. Now, if someone asks you, then what will be the another solution? Then you would say, for the another solution, you have to wait for the further 2 pi length of interval. So once you travel further 2 pi length of interval, this is what your next solution will be. 7 pi by 6, and then we have another solution is 2 pi plus 7 pi by 6. And you keep getting different solution at a 2 pi length of interval. If someone asks you to generalize this solution, then general solution is given by this formula. It is 2n pi plus 7 pi by 6, where your n can take any integral values. Let me take one more to explain how we can get the common values of x if more than one trigonometric function are participating there. Here we have two, this time sine and tangent is there. So first of all, assemble the terms of sine x separately and do the same thing with tan x. So we have sine square minus sine x, and then we have 2 times tan square x plus 2 over root 3 tan x, correct? And we have a constant term, it is positive 11 by 12. Now we have a quadratic in sine as well as in tan. Do try to convert this quadratic expression in trigonometric function into perfect square. I'm sure you know how to convert any expression into perfect square. For that one, I'll be adding 1 by 4, adding and subtracting 1 by 4 in the first expression. So I end up getting sine x minus 1 by 2 whole square. And to compensate it, I further need to subtract 1 by 4. Do the same thing with this tan function there. We end up getting tan x plus 1 by root 3 whole square. If I add and subtract 1 by 3 there. So let me subtract it there to compensate your 1 by 3 plus 11 by 12, it is equals to 0. Now, once I simplify this expression, I wonder that only sin x minus 1 by 2 whole square as well as 2 times tan x plus tan x plus 1 by root 3 whole square is there. Now square of two different entities, sum of square of two different entity is equals to 0. The only possibility which I can observe is that this expression should come to a 0. So by that logic, if you want any solution, then it will occur, sorry, it may occur when sin x is 1 by 2 and tan x will give you negative 1 by root 3. Now again we are struck with the same problem. Sine will give you positive response where sine is positive in coordinate number 1 and in coordinate number 2, wherever tan is negative in coordinate number 2. So if there is any value of x, I'm sure it will be from coordinate number 2. Now what value of x will give you 1 by 2 in second quadrant? Specifically, if I'm talking about sine function, then you know the only value of x from quadrant number 1 is pi by 6. And if I want to get a value from quadrant number 2, I have to use this identity that sine pi minus theta is equals to sine theta. There we go. I get the value of theta in second quadrant. So it is 5 pi by 6. It is 5 pi by 6. But still, I'm not sure whether tan will give me this, desired result at that particular angle. So for that one, or just for your verification, you just need to find the value of tan 5 pi by 6 separately. And you know, tan 5 pi by 6 is nothing but tan pi minus pi by 6. Tan pi minus theta stand for negative tan theta. There you go. We are getting the same result. That means we get the one of the value, that is 5 pi by 6, which is satisfying this equation. If you want more solution, then you need to keep adding multiple integral multiple of 2 pi each and every time. So let me write down its general solution there. It's a general way to express all of this solution is 2n pi plus 5 pi by 6, where your n can be any integral value. I'm sure this lecture is helpful to you to understand how do we get the solution of trigonometric equations. Thank you very much.